Hello guys, my name is Devin. My YouTube channel is DRG Bros. Today we're going to be talking about differential equations. So, first off, what is a differential equation? So, an algebraic equation you might have heard of, like something like x squared plus 7x plus 12 is an algebraic equation with an answer of x plus 4 x plus 3. That's an algebraic equation. Now, in algebraic equations, your goal is to find numbers that satisfy the equation. So in this case, solving it out, minus 4 would work. See, minus 4 squared is 16, but minus 4 times 7 is minus 27, or 28, sorry. Minus 28 plus 16 is minus 12, and minus 12 plus minus 12 equals 0, which is actually the point of these equations, to find it that equals 0. So, in a differential equation, we try to find functions. In an initial value problem, or IPP for short, we find a function that satisfies the differential equation. If we find a function that satisfies the equation. So, one second guys, I'm just checking. Okay, so we're going to use the differential equation. I'm sorry guys, I can't find the equation. I wrote everything down. Alright, whatever. So, the equation... Oh, here it is. My bad. So, what we're going to be doing, we're going to be solving in this episode, it's a pretty famous equation. I think, anyway. 2 prime x minus 5f, the first prime x, plus 6f of x. You see, it's the same thing as the equation above, but we're looking for functions. So, our initial value problem, we have the initial values. The f to the function of 0 is 2, and it's 5, like this. Okay. So first, we're going to say that f of x is equal to e to the rx, okay? Which is f prime, if we differentiate this, is going to be r e to the rx. And then if we do it again, it's going to be r squared e to the rx. Now, I'm not going to show it here because it's not necessary, but if you did it f3 prime, then it would be r cubed e to the rx. Okay? So now we're going to replace them. So we have r squared e to the rx minus 5r e to the rx plus 6 e to the rx equals 0, like this. Okay? And what we can do now is we can divide everything by e to the rx, like so. Even the 0, because we have to do that. And then this cancels out, this cancels out, this cancels out, and this cancels out. So then that leaves us with r squared minus 5r plus 6 equals 0. Since 0 is 0, divided by anything, it doesn't matter. Which, this is a characteristic equation. So an algebraic equation could be this equation, but instead of r's, it's x's. If it's like a different variable, then it's a characteristic equation. So we solve this, which is r to the minus 3, r to the minus 2. And just in case you guys don't know how to solve this, you want to find an answer like this. So first you're going to split this into two numbers that multiply together. In this case, it's r, and they multiply to r squared. Then we need to find out two values here that when this times this and this is added, it equals this, and when this and this are multiplied, it equals this. So, I know that's kind of complicated, but minus 3r minus 2r is minus 5r, and minus 3 times minus 2 is 6, so this satisfies the equation. Equals 0. Don't forget about that. Then we have r equals r minus 3 equals 0, or r minus 2 equals 0. And I know this is kind of funny. You normally wouldn't use the word or in math like this, but we're going to do it here, okay? So that means that r is equal to 3, or r is equal to 2, which means that r's values are 3 or 2, okay? So, noting that, now we have to find, now we get a general solution of this. So we have f of x equals c1 e to the 3x plus c2 e to the 2x. You see, we're replacing r with these values that we found. But we have to find out what c1 and c2 is. I know I wrote a plus sign, but that's and. Okay. So what we can actually do is we can solve this as like a 2x2 linear systems. So at this point in the video, I'm just going to say this right now. If you don't know how to do it, I suggest watching Dylan's video on it. I'm pretty sure he did one on it. I highly suggest watching this video and then come back because, yeah, my answer isn't going to make sense to you if you don't really know how it works. So C1 and C2, we can write it like this. So we have f of 0 equals C1 e to the 3 0 plus e to the 2 0. Or, there's no parentheses there, my bad. And then we have f of 0, or f prime of 0 is equal to C1 3e 3 0 plus C2 2e 2 to the 0. Now that's kind of a mouthful, but we go. Which we can then simplify down to 2 equals C1 plus C2, 5 equals 3C1 plus 2C2. And in one of his videos on linear systems, Dylan mentioned that you don't have to use x and y for a linear system, but you can use other things. Like, I think in his example, he used x1, x2. We're doing the same thing, except this time with c. So if we flip this, we have c1 plus c2 equals 2. 3c1 plus 2c2 equals 5. Now, again, I'm going to say this right now. I highly suggest you watch Dylan's video on this to get a better understanding of what we're doing here, okay? And as an exercise, if you want, you can pause the video here and try to solve this equation. Okay? So when we solve this equation, we're going to come that C1 is equal to 1 and C2 is equal to 2. Okay? So the solution to the problem is f of x equals 1. We don't have to write 1, but these are the c's. 1 e to the 2x plus 1 e to the 3x. Simplified is f of x equals e to the 2x plus e to the 3x, like so. Thank you guys very much for watching this video. I hope you enjoyed, and I hope I'll see you for another video. Bye, guys.